This video is just going to review the systems of units that we'll be using in our electric circuits class. So the first two, length and mass, we won't actually see them very often in this class because we're dealing with electrons moving, and we're not really worrying about the distance they're moving, and the mass electron is kind of negligible for this, so we really don't focus on that in this class, but in the few times we will use it. The standard unit for length is a meter, symbol just M, and the standard unit for mass is a kilogram, or just kg. We will use measurements of time here and there in the class. The standard is a second, symbol S, as usual. Then let's get to some things that are really dealing with electricity here. So the next is electric current. The unit for that is an ampere, and the symbol is a capital A. What current is measuring is how fast your electric charge is moving through your system in some sense. So if you have a lot of charge moving very quickly, that would be a high electric current, and similarly, if you didn't have very much charge moving at all, a low or zero current. And if we want to talk about charge by itself instead of just moving, electric charge, the unit is a coulomb, capital C. And we do have a relationship here. 1 coulomb is 1 amp times a second. Or in other words, you could think of this as, if you wanted to say what does 1 amp mean, it means there's 1 coulomb per second traveling in that system. The next one here, electric potential. I'm going to have a separate video just trying to talk about what this really is. It means, but this is what people normally refer to as voltage. The unit for that is volts, capital V. And there's a relationship here between voltage and some of our other units, but we don't really use that relationship very often. In fact, the majority of our problems, we are going to give you a voltage source and tell you that this voltage source is this many volts, and therefore we don't need to solve for it, or in some sense. Anyways, so we don't really need the unit conversion there, but it is true. The next one is one that, again, we are not actually going to deal with that often in this class, but in other circuits classes you will spend a lot of time on it, and that is power. Unfortunately, it's just not a main topic for us, but power is how fast, how much voltage, essentially, how do I say this right? It's energy per time. So how much energy are you using in your system over a given amount of time? That's our power rating here. Then we have 3 things that are going to be coming up in different circuit elements. A resistor, we will measure its resistance. An inductor, we will measure its inductance. And a capacitor will measure its capacitance. Of course, any real-life object could have some properties of any of these 3 things here, not just necessarily one of them. You can have combinations. But for us in this class, we are just generally dealing with ideal circuits, and so we will have something that is just a resistor, period, something that is just an inductor, period, and something that is just a capacitor, period, even if realistically that's not how it works. For resistance, the unit is ohms, and we use the Greek letter omega here. For inductance, it is henries, capital H, and for capacitance, it is farads, or capital F. Also, later in the class, we're going to be dealing with AC circuits, and in that case, you're really going to care about the frequency of what's happening here. And frequency is measured in hertz, which is Hz. One quick little note here, which we'll go into more detail in much later videos when we get to that section, is that there is a frequency that we have here, and there's also an angular frequency. Omega is 2 pi f. So this is something that we are going to have to deal with later on, but for right now I'm just giving you a quick reminder of that fact. And then in the bottom table here, these are the different prefixes you might have. We aren't going to deal with all of these very often. Tera and Giga, I can't think of anything we're really going to use those for. On the small end, nano and pico, we might have that for a capacitor, nanofarads or something. But for the majority of what we're going to be dealing with, it's going to be just kilo, milli, and micro for things that we have. But you should know all of these. You should be able to convert between them depending on the context.